Hello everyone, and welcome to this final video on sketching polar curves. In this video we're going to have a look at a type of polar graph which is referred to as polar rose or a lemniscate. So these are the final two types of graphs you need to be familiar with. Just to remind you, you are generally given the graphs in the exam. But I think it's useful to know what they look like when you see an equation. That just helps with your fluency and with your understanding. And as I also said in the previous two examples videos, we will be going through this in detail in lesson. This video is just to give you an overview of what these graphs look like. Okay, so polar roses are in the form r equals a sine n theta and r equals a cos n theta. And n determines the number of leaves that this rose will have. So if n is an odd number, then I'm going to have n leaves. And if n is even, I'm going to have an even amount of leaves, so 2n. You might recall from the first video we looked at r equals a cos theta and r equals a sine theta. And in each case, we had a circle. And in the case of cos, that circle was centered, had symmetry about the initial line. And for sine, we had symmetry of that circle about the pi by 2 axes. So that's what they look like. As we increase the value of n, for r equals a cos 2 theta, this is now even. So I'm going to have 2 times 2 leaves in this graph. And this graph will look like this. I'm going to start there. It's going to dip down there. Go up there. Up there. And come back to 2 pi over there. And in each case, this is going to be the value of a. So 4 leaves, a cos 2 theta will look like this. So I've got twice as many, if I think about my sine curve, I've got twice as many curves between 0 and 2 pi. So you can see in each case there I'm going to have 4. Each section represents one of the petals or leaves, which is the formal term. Okay, so let's have a look at what r, if r equals a cos 3 theta looks like. Well, in this case, I'm only going to have 3 petals, and the reason for that being is actually because they overlap. They occur more than, that it repeats over itself. So I end up getting this. It does that again. So it's not a great drawing, but that is what it looks like. And in this case, that's going to be A. And if you're wondering what these angles are here, that's actually going to be the line 2 pi by 3, 120. And that's going to run through the angle 4 pi by 3. And then obviously I have this here again. Okay, so that is r equals a cos 3 theta. So you can see that then if I go from 2 theta, which was 4 leaves, to 4 theta, which would be 8 leaves, 4 times 2, so 8 leaves. Going to draw this out. It's going to end up looking like this, but obviously having the same size petal in each case. and sorry about that, the value here each time on the axis is a. Okay, so that is r equals a cos 4 theta. Okay, so in the next example, example 4, we're going to have a look at r equals a sine 2 theta. And remember, sine has got symmetry about the pi by 2 axes. That's where which we looked at initially. So 2 theta means there will be 4 leaves. And I'm going to start at 0 because sine of 0 is 0. So a times sine 0 is just 0, so r is equal to 0. So it's actually going to end up looking like this. And not a great graph, but it's essentially the cosine polar of rose, but it's been rotated. So you can see that there is symmetry on the y-axis there. For r equals a sine 3 theta, it's an odd, n is odd, so I'm going to have 3 leaves, and it's going to look like this. Start there again, dips down here, and then comes back up here. And again, just out of interest, should have done that with the previous one as well. This is going to be going through pi by 6. This will be 5 pi by 6, and that's the 3 pi by 2 axes. Just going back here, that's going to be between, let me just work that out, pi by 4, that's going to be, yeah, exactly pi by 4, and 3 pi by 4, and so on. So you can work out each of those angles. And then if we look at sine of a sine 4 theta, even number, so I'm going to have 8 petals, but instead of starting on the initial line, it just is going to look like this. Right, add these two. Again, not a great drawing, but the best I can do with this diagram. Okay, and there we go. Just to let you know, this is going to go right through the middle pi by 4, so you can therefore work out what these two axes will be. That's going to be pi by 8, 3 pi by 8, and you can work the rest out accordingly. Okay, I hope that bit was useful. These are my polar roses. So let's move on and look at the very final section, which is the lemniscates. They only come in this form, r squared equals a squared sine 2 theta, and r squared equals a squared cos 2 theta. And they are always going to be in the same form. The first one is going to look like this, and the second one is going to look like this. Okay, so in each case you can see the difference between the two, and those are the lemniscates, and we can calculate these angles. That's going to be at pi by 4, goes through 0, and we know that cos of 0 is 1. Cos of 0 is equal to 1. Therefore, r squared is going to be a squared times by 1. So r is just a. So these values in each case will be a. And there we go. We will spend more time next lesson talking about these graphs, but I hope that has given you a good idea of what to look out for and how to the general form of each different equation. As always, if you have any questions, please do let me know.